Here's a number that should bother you. 13.8 billion years. That's how long the universe has been running. Now here's another one. 300,000 years. That's roughly how long anatomically modern humans have existed. Do the division. We've been here for about 0.002% of cosmic history. Most people hear that and nod and move on. They shouldn't, because that arithmetic implies something that rarely gets said plainly. The universe ran for nearly 14 billion years before anything recognizably human showed up. 14 billion years of stars being born and dying, of planets forming, cooling, cracking open into complexity. And in all that time, there's no particular reason, none, not one physical law that says we had to be the first. Let me take that seriously for a minute. The Sun is 4.6 billion years old, average age for a star in this galaxy. But the Milky Way has been forming stars for 13 billion years. That means stars like ours, G-type, stable, long-burning, were forming and reaching maturity 8-9 billion years ago. Rocky planets form around stars. We know this. We've confirmed thousands of them now with Kepler and TESS and direct observation. The chemistry that builds rocky planets is universal. Silicon, oxygen, iron, magnesium. These elements were already abundant in the galaxy 8 billion years ago. So you have a rocky planet, say 8 billion years old, orbiting a stable star in the habitable zone. The same basic conditions that produce life on Earth, liquid water, organic chemistry, time operating 4 billion years before Earth even condensed out of a cloud of gas. What happened on that planet? We don't know. That's the honest answer. But we don't know is not the same as nothing. Those are completely different statements, and confusing them is how we make the first mistake in thinking about this problem. Here's what we do know. On Earth, once liquid water existed stably, around 4.1 billion years ago, evidence for life appears within a few 100 million years, maybe faster. There are disputed isotopic signatures of life in rocks 4.1 billion years old, undisputed microbial mats by 3.5 billion years ago. The chemistry of life, when given water and energy and time, seems to happen, not guaranteed, but not vanishingly rare either. The window between habitable and inhabited on Earth was short. If that's a general rule, and we have exactly one data point, so be appropriately humble here, then planets around old stars might have done this a long time ago, not just started life, gone through billions of years of evolution, longer than the gap between bacteria and us. Now here's where it gets worth thinking about carefully. Humans have had radio technology for about 120 years. We've had agriculture for 10,000 years. Complex writing for maybe 5,000. We went from hunter-gatherers to landing on the moon in something like 300 generations. In cosmic terms, that's instantaneous. If you scaled the history of Earth to a single calendar year, industrial civilization occupies the last 30 seconds of December 31st. A civilization around an 8 billion year old planet, if it had followed any remotely similar trajectory, would have had a head start measured in billions of years. That's not marginally more time than us, that's incomprehensible amounts of time. A billion years ago on Earth, the most complex organism was probably something like a sea sponge. A civilization with a billion-year head start over us. I can't even construct what that looks like. Neither can you. The honest statement is that our categories probably don't apply. But here's the part that gets genuinely strange. Most of those civilizations, if they existed, are gone. Not necessarily destroyed, not necessarily killed off. Just gone. The way everything eventually ends. Stars don't burn forever. The sun will leave the main sequence in about 5 billion years, expanding into a red giant, sterilizing the inner planets. Any civilization around a star like ours has a natural clock. The universe isn't static. It's a story with a beginning and a middle, and a direction toward cold, dark, maximum entropy. The civilizations that arose first had the longest head starts, but they also faced the end first. There's a term for this, used by astrophysicists studying what they call the cosmic star formation history. Most star formation in the Milky Way happened between roughly 8 and 11 billion years ago. That peak is over. We're in a quieter era now, which means most of the planets that are ever going to exist in a form similar to ours, around stars similar to ours, most of them are older than Earth. We're late arrivals to a galaxy that was doing its most active period of work long before our sun switched on. Think about that arithmetic again. If the distribution of potential civilizations tracks even roughly with planetary age and stellar habitability, The median civilization in the Milky Way, the one in the middle, if you ranked them all by age, would have arisen not 300,000 years ago, but billions of years ago, and would have faced the consequences of that accordingly. Now, I want to be careful here because this is where people start making confident claims that the physics doesn't support. Nobody has detected an alien civilization, not one verified signal, not one artifact, not one piece of evidence that survives serious scrutiny. The fact that we've been looking more seriously in the last 60 years with radio telescopes and more recently with optical searches and anomaly detection in stellar light curves and found nothing is itself a data point. It's called the Fermi paradox. Fermi's actual question was simpler and sharper than most summaries suggest. Where is everybody? If the universe is old enough and big enough for other civilizations to have arisen and spread, why don't we see them? The honest answer is we don't know. But there are a few things worth distinguishing. One explanation is that we're genuinely alone, that life or intelligent life is so improbable that it's effectively unique. The physicist Enrico Fermi didn't think this was likely, but it can't be ruled out. We have one sample. Statistics with one sample are treacherous. What I can tell you is that the chemistry of life, amino acids, nucleic acid precursors, simple organic molecules, shows up everywhere we look, in meteorites, in molecular clouds, in the atmospheres of gas giants. The chemistry of life is not rare. Whether the step from chemistry to self-replication is common or extraordinarily rare, we genuinely don't know. Another explanation is that intelligent civilizations tend to be short-lived. We've had nuclear weapons for 80 years. We've known how to alter the climate for less than that. The window between develops technology and destroys itself might be narrow. If most civilizations collapse before they become detectable, before they start transmitting recognizable signals or engaging in detectable megastructure engineering, the galaxy could be full of ruins we can't see, dead planets where complex chemistry once organized itself into something that looked at the sky. This isn't mysticism. It's a straightforward consequence of timescales. If a civilization lasts, on average, 1,000 years at the technological level required for us to detect it, and there are a million such civilizations spread across the galaxy's history, and the galaxy is 13 billion years old, the chance that any two of them overlap in time is tiny. They're separated not by distance but by when. Two candles lit at different moments in the same room would never illuminate each other. There's a third possibility that I find genuinely hard to reason about. Civilizations that survive long enough effectively become undetectable to us. Not hiding, not silent, just operating at scales or in modes we don't recognize. A civilization a billion years ahead of us might as well be supernatural from our current vantage point. We wouldn't necessarily know what to look for. We're looking for radio signals because we use radio signals. That's like a tribe that communicates by drumming, listening for drums from the stars, while the rest of the universe switched to fiber optics 4 billion years ago. I don't say this to make you feel small. I say it because it's the honest physical situation. Here's the actual number that deserves more attention than it gets. There are approximately 100 to 400 billion stars in the Milky Way. Of those, roughly 20% are G-type stars like the Sun, and a comparable fraction are K-type stars, which are cooler and longer burning, potentially even more favorable for long-term habitability because they live longer. Measurements from Kepler suggest roughly 20 to 50% of Sun-like stars have at least one rocky planet in the habitable zone. Apply the most conservative numbers. If even 1 in a million of those planets ever developed technological civilization, that's tens of thousands of civilizations across the galaxy's history. Tens of thousands. Most of them older than us. Most of them already finished. There's a phrase I want to examine for a moment because it gets used wrong. Civilizations more advanced than ours. More advanced. As if there's a single track and everyone's running the same race at different distances. That's almost certainly not how it works. Evolution on Earth took wildly different directions on different continents in response to different pressures. The diversity of life on Earth is not a ladder, it's a bush. Civilizations under different stellar conditions, different planetary environments, different gravitational constraints, different chemical starting points. They didn't run our race. They ran their own. What more advanced might actually mean, if we're being operational about it, is more capable of influencing their local physical environment. More energy available, more information processing. By that measure, a civilization around a star 8 billion years old that survived, and that's a big if. would have access to and capability with physical processes we don't have good intuitions for yet. Kardashev tried to formalize this. Civilizations that use the energy of their planet, their star, their galaxy. We're not even solidly Type 1 yet. We don't command the full energy budget of this planet. Now the question that actually matters for the science, how would we know any of this happened? This is where the rubber hits the road. And the answer is, with our current tools, mostly we wouldn't. Biological remains from a civilization that collapsed 1 billion years ago. Gone. Not degraded. Not buried. Gone. The geological record doesn't preserve much past a few 100 million years. The Atlantic Ocean didn't exist 200 million years ago. The continents have been recycled by plate tectonics multiple times over in 4 billion years. If there were footprints on an old seafloor, that seafloor has been subducted into the mantle. There are researchers, Gavin Schmidt at NASA's Goddard Institute is one, who have thought seriously about what we call the Silurian hypothesis. Could we detect evidence of a prior industrial civilization on Earth itself? The answer is unsettling. Probably not, if it happened more than about 100 million years ago. We might find isotopic anomalies in geological strata, patterns in carbon or nitrogen ratios that don't match normal geological processes. But those signals are subtle, ambiguous, easy to miss or misinterpret. We barely know what to look for. For civilizations on other planets and other star systems, the problem is even harder. We can measure atmospheric chemistry remotely through spectroscopy, looking for what's called biosignatures, oxygen, methane, certain ratios of gases that don't stay in equilibrium without biological processes. But those signatures fade when life ends. A planet that was inhabited 1 billion years ago and is now dead might look chemically identical to a planet that was never inhabited. We'd have to catch the planet during the inhabited phase, from 4 to 100 light years away, with telescopes that currently don't exist. What we might catch, if they're out there, technosignatures, nitrogen dioxide from industrial processes, chlorofluorocarbons or other synthetic chemicals, waste heat from energy use at civilizational scale, radio leakage, laser pulses, the light curves of stars being interrupted by megastructures. Most of these signatures also fade quickly, decades to centuries, not millions of years. The window during which we'd be detectable is narrow, which means theirs probably was too. So here's where we end up. The universe is old. Rocky planets form around old stars. The chemistry of life appears spontaneously in space. The fact that intelligent life arose on Earth isn't evidence that it's common, but it's not evidence it's unique either. Given the numbers, the prior probability of other civilizations existing somewhere in cosmic history is not small. It might be quite large. But civilizations are temporary. Stars die, planets become uninhabitable. Even civilizations that don't destroy themselves face eventual endings. And the timescales of cosmic history are long enough that most civilizations that ever arose probably arose and ended before the sun was a smudge of gas in a young molecular cloud. The galaxy may be full of graveyards. Not metaphorical graveyards. Actual planets where complex chemistry once arranged itself into things that wondered about their own existence, built structures, burned energy at enormous rates, maybe looked up and asked the same questions we're asking now, and then stopped. Not necessarily because they failed, sometimes because the physics just ran out. The reason this matters, and I want to be precise about why it matters, rather than just gesturing at profundity, is that it changes the frame for how we think about our own situation. We tend to think about the future. Will we survive? Will we expand? Will we encounter others? But the more appropriate question, given the arithmetic, might be, are we the audience for a story that mostly already happened? I don't know. Nobody does. That's the honest endpoint. What I know is that the universe has been running long enough, at scales large enough, with chemistry favorable enough, that the silence we're currently observing isn't reassuring evidence of uniqueness. It might just be the silence of deep time. The civilizations that arose first would be gone by now. Their light, their signals, their artifacts scattered, degraded, subducted back into the indifferent physics they momentarily organized themselves against. We're 300,000 years old. The universe is 13.8 billion years old. That gap is not empty. We just can't see into it very well yet. And what we do with that uncertainty, whether we take seriously the possibility that we're not early arrivals but late ones, that the question isn't are we alone, But how many came before us? That seems to me worth thinking about carefully, not with awe for its own sake, but because it has actual consequences for how we look and where and what we decide to do with the time we have.